This is our 36th lesson on the study of the biblical flood. I'm Marion Fox, the teacher of the class, and we'll be continuing through probably up into next year sometime. This is the year 2021, and this is the month of October. We were looking at the magnetic field and the changes in the magnetic field, changes in Earth's magnetic field. We're going to be looking at several factors in this. One of the things that they use to supposedly measure the age of the Earth is the magnetic field remnant. That is, this is basically a remnant. You think of it as a remnant of a magnetic field. That is, what it did is the lava is hot, and then when the lava cools, it lines the magnetic particles, the iron and nickel and cobalt. Those are ferromagnetic materials in the natural form. Those elements, those three elements are, and they'll be aligned as permanent magnets. And so what the field was whenever the lava was molten and is displayed. And that's probably good thinking. I don't see much wrong with that. But the problem that they get into is they assume that this occurred over thousands of years of time. And so they get into a problem with that in that they have used uniformitarian geologic assumptions in order to do the dating process. But remember, they've already rejected uniformitarian geology in one of the first 2 or 3 lessons. We showed that and documented that. So again, they come back to it. And so let's read this, if we might. One of the lava flows was 2 meters thick. And this is the British spelling of meters. And a second 1.5 meters thick. The thicker lava would have taken 2 weeks to solidify from its outer surface through to the interior, and the thinner one slightly less. The magnetism of the rocks from the surface to the center of the lava flow acts like a natural compass needle, recording the direction of the surrounding magnetic field at the time each part solidified. Coe and his colleagues found that the needle swung through 50 degrees in the first case and 48 degrees in the second. The observation implied at the time the lava was cooling, the magnetic poles were moving between 3 degrees and 8 degrees a day. They're moving that much per day. And so that's very interesting. Of course, my model would explain that as a planetary body moved around the Earth, it would move that field. Its field would line up and then be in the state of motion as the planet moved around the Earth. Now, we'll show a diagram for this in just a minute right here. What we have here is if the planet is moving, then it would move, taking 50 days to circle around the Earth. And as it moved, the magnetic field would be moving, its magnetic field, and it would move through the molten rock as the rock cooled. So this would be, and when you think about it, this motion here, what he said, between 48 and 50 degrees, about 3 to 8 degrees a day, that would fit pretty well with what we see with the model here, my model. This magnetic field moving as it cuts through, and it cuts through the lava that's being made. Now, as the Earth spins and its rotational speed changes due to the change of angular momentum, transfer of angular momentum from one object to the other, the planet here, and I believe this to be Mercury, this would move and shift, and that would create the lava flows. And so evidence is pretty clear to me, and we'll show more evidence later, that there was volcanic activity during the flood as well. And when we see it moving, then the magnetic field then comes down and moves down. Let's go back to this one. As the planet moves down, the field is going here. And then as it comes down here, it's moving more like this. And so it's moved several degrees in a several days time as it moves across here. And, this is the time frame here. This is not moving around real close to the Earth. It's several thousand miles away. We'll get Roche's limit and show how close the nearest it could have been, and without fragmenting the planet Mercury. Okay. Now, Coe and Prevost, they continue. Thus, the balance of evidence now in hand weighs in favor of a rapid geometric field variation. So they argue it was rapid. Well, my model would explain the rapid variation. The question then arises whether the source of this variation was inside or outside the Earth. The rate of change of at least 300 gammas a day is much greater than the secular variation of internal field observed in modern times. So the rate of change, and so this is bigger than what they observe in modern times. Of course, I believe that the magnetic field of both Mercury and the Earth has been deteriorating since that time, decreasing or diminishing or going down in value. Now, Increnes, Bibbering, and Blanc write, slow variation from time has been established from the magnetic inclination, and for the magnetic field intensity was decreased by about 20 gammas per year. Now let's go back 20 gammas per year, and it was at least 300 gammas. The rate of change was 300 gammas per day during this time. And of course, I believe the interaction of the two magnetic fields, as we go back, the magnetic field of the Earth and the magnetic field of the planet, which I believe to be Mercury, these fields would have interacted and changed as one aided the other, two fields interacting. So this would explain it quite well. Now, McDonalds Guns, which is published by the United States government, they claim that the Earth's magnetic field decays in a linear manner and that it will cease to exist in 3991 AD. That's their prediction. So this is a book that is published by the U.S. government. I have a copy of it, and but it's very interesting. They claim it's a linear manner. The decay of field is linear. Now, we'll talk about that in just a minute. There's some real serious implications to that claim. And let me point out here, I've done graduate work in mathematics and physics and electrical engineering, all three. And it would be a rare occurrence indeed for something to decay in a linear fashion, as McDonalds Guns claim, rather than an exponential fashion, as Barnes claims. Now, I cited a book by a man named Barnes. I believe he's dead. He was a physics professor, I think, in a university in Texas. Anyhow, I have his book, and it's a very good book, and I believe it. He has a lot of good information for your consideration, but I cited in my book. Barnes has written an excellent treatise on the magnetic field of the Earth, and this author, that is me, I do not know of anyone who's answered all of his arguments. They've attempted to answer some of them, but I don't believe they've given answers to his arguments. Now, when we look into the mathematics of something in the physical realm, everything that I know of that I've ever seen, including growth of bacteria and all kinds of things, they decay in an exponential fashion, following an exponential form. They don't decay in linear fashion. Now, if you use a process in mathematics called Fourier Analysis, F-O-U-R-I-E-R, Fourier Analysis, we learn that the linear decay of anything creates a wide range of harmonics. If you take something, you can hear the harmonics. If you rub on something that's rough, it'll create all kinds of sounds and scratchy sounds. But these there is a mathematical relationship to those sounds, and it can be modeled with the Fourier series. It's called Fourier series, but Fourier analysis. And in my graduate work in electrical engineering, I did this quite a lot, used it quite a lot. But what we would learn is a linear decay would generate a wide range of harmonics, and these are sounds or vibrations, or this would be magnetic fields moving in different directions. These harmonics would appear as field reversals in the remote magnetism of the rocks. So if it is linear, we're going to get that remote. We're going to get that from Fourier analysis, the Fourier series analysis. We're going to get a wide range of harmonics, and a harmonic is a multiple of a frequency. So if we had a tone of 440 hertz, I believe that's middle C. And if we had a tone of that, then what we'd get, the second harmonic would be twice that frequency, 880. Third harmonic would be 3 times 440 and so forth. There would be a whole number of multiples of it. There is a pattern to it. And so what we get is we would get that pattern. We get these changes in the magnetic field that would alternate in alternate directions. It'd go one way and then the other. And so we would get this, what we actually are seeing. Things in nature, in my experience, just do not decay in a linear fashion. They decay in an exponential fashion. But if we assume that it is in a linear fashion, we would have a ramp like we see right here. And you can find this on the internet, but this doesn't come out very well. But this is the Fourier analysis. And what you're going to get is they can model it, and it's going to generate a wide range of frequencies. I've modeled these things and did the mathematical model, and then we go in and actually measure the frequencies that are there. You can actually measure them with instruments, and they're present. So this is a ramp, and this is another ramp. That is and these aren't following what's called a sine wave. Everything in nature wants to make anything that's moving into a sine wave. And the sine, S-I-N-E, is this function. It graphs this smooth curve here. Everything is a sine wave, or a sinusoid. It'd be a sine or a cosine wave. Cosine is just a sine wave shifted by 90 degrees. It's a difference in phase. But what we get here is all of these together make up this one waveform. And so we get a pattern here from Fourier analysis. Now, I'm not going to go into Fourier analysis anymore because it gets into some advanced mathematics. You have to have some calculus. It's usually taught in calculus. And I've had a few courses in calculus. I had 27 semester hours of calculus in college. But I've done the Fourier analysis in some detail, and I've taught it. But the Fourier analysis will explain if you agree that it's linear, it's decaying in a linear fashion, we would get the appearance of alternation in directions, or rotation, or change the direction of the magnetic field. Here's a link, and there are other links you can get in type Fourier series analysis. This is a link. This is the Khan Academy, and this pretty good source to study it. If you have some mathematical background, you can study it in some more detail. Studying mathematics usually include the study of the Fourier series analysis. There are other series. There's Taylor and Maclaurin series and other series. But the Fourier series is something a little different. More information about the Fourier series can be found on Google. You can just Google and type Fourier series. Okay. Now, I won't spend any more time on that. But I'm convinced that these fellows come up with this have not considered that possibility, and probably most of your geologists don't have a background in mathematics where they even have heard of Fourier series, and don't understand that if it's linear, in fact, it would have created all of these harmonics, and it would change direction. The magnetic field would alternate back and forth and changing direction following these harmonics. Now then, there are several kinds of magnets in the area if you study physics. There are temporary magnets. This is a material that an outer source, an external source, can temporarily magnetize it. That is, align the magnetic moments, and so that it's temporarily magnetized. And I remember taking a bar magnet, would pick up a tiny nail, and it would be magnetized, and we could take a very small nail, and that temporarily magnetized nail would pick up a smaller nail. And so it was temporarily magnetized. When you pulled it away from the magnet, the nail that was attached to it, the small one attached to the larger nail, would drop away. You can see that. That's usually taught in elementary school, even certainly in junior high. And so we have permanent magnets. This is something that can be magnetized and stay magnetized. When I was younger, they had some fairly strong ones that were used in some of the what we call klystrons and magnetrons. Magnets were very, very strong. But now they've got some ceramic magnets that are just super strong. They're just exceedingly strong. And so they've come up with some new ceramic materials that will have some strong magnets. Temporary magnets, permanent magnets, and then electromagnets. An electric field would create a magnet. And so we can tap the field and wrap it on itself with wraps of like a coil around it and get a very strong magnetic field. This is how electric motors operate. And so they create a magnetic field. So we have temporary, permanent, and electromagnets. Now, right here is a bar magnet, which is generally called a bar magnet, and it has a north-south pole. Now, the magnetic field supposedly goes out from the North Pole and circles around and goes into the South Pole. Supposedly, that's what they're claiming. But what we get is there is something occurring here. And again, I'm not sure that they understand as much as we can model magnetic fields quite readily with mathematics. But just understanding what's really happening, I'm not certain that they have as much information as they do in other areas. The magnetic field, we model it, we can predict what it's going to do under certain conditions. This is a permanent magnet here, and we take iron filings. We have a north-south pole on a bar magnet. These iron filings then line up, and what I would do when I would teach this, I would put on a bar magnet, I lay a sheet of white paper on top of it, and then I would sprinkle the iron filings and kind of tap the edges of the paper just slightly, and then they would line up in these lines. You could actually see this. And of course, and then the iron filings wouldn't be stuck to my bar magnet. They'd be on top of the paper. I could put them back into the container where I had them to demonstrate it. So this worked pretty good, but these are temporary magnets here, and they line up. And the magnetic field tends to go from the north to the south pole, goes around in these circles. So it goes around. There is a pattern to it, and it's like the field of the Earth itself. Then there's electromagnets. This is called a solenoid. If you have a automobile, most cars have solenoids to make the starter kick in and to start the engine. And what we have here, this is a wire. These circles here represent wires. You cut away view of the wire. The current is flowing into the wire and wrapping back around, coming out this other side of the wire and wrapping around, circling through it. And the current then creates a magnetic field. Every electron is a tiny magnet. And when these electrons get lined up and they get to moving, and billions of them get to moving, and maybe even many billions moving in 1 second across the point, then the tiny magnetic fields of each little magnet, each electron's a magnet, then they will add, they'll be additive, and they'll add to it and create a very strong magnetic field. This can be measured, and of course, I remember doing this whenever I was in the 6th or 7th grade in junior high and elementary school. Okay. Magnetic materials. Now let's look at diamagnetic materials. Now this is something new for us now. Diamagnetic materials have a weak negative susceptibility to magnetic fields. Diamagnetic materials are slightly repelled by a magnetic field, and the material does not retain its magnetic properties when the external field is removed, so it won't stay permanently magnetized. But what it does is slightly repelled by it. Now there's a repulsion there, say, diamagnetic materials. Most elements in the periodic table, including copper, silver, and gold, are diamagnetic. Most elements are. Now, so diamagnetic is slightly repelled by it, and it won't stay magnetized when the external field is removed. Now, we have paramagnetic materials. They have a small positive susceptibility to magnetic fields, and these materials are slightly attracted by a magnetic field, and the material does not retain its magnetic properties when its external field is removed, so it won't stay magnetized. Okay, so that's a paramagnetic. Paramagnetic materials include magnesium, molybdenum, and lithium, and tantalum. So these are some of your materials that are paramagnetic. Gadolinium, gallium, garnet is paramagnetic as well. There's other things. Garnet stone is what I'm talking about. A ferromagnetic material, and you can, if you've studied chemistry, the word ferro is the Latin word for iron. Ferromagnetic material acts like iron. They have a large positive susceptibility to an external magnetic field. They exhibit a strong attraction to magnetic fields and are able to retain their magnetic properties after the external field has been removed. They can be made into permanent magnets. And so that's a ferromagnetic. So we have three kinds. We have diamagnetic, is slightly repelled. Copper, silver, gold, and magnetic. Most of the elements on the periodic table are that way, are diamagnetic. Paramagnetic. Paramagnetic materials, what we'll tell you later is if you get it cold enough, if you cool it off, it can have a strong magnetic field. And the magnesium and molybdenum and so forth, these elements. Ferromagnetic, iron, nickel, and cobalt are the ones that I was taught when I went in school. But now they've come up with new materials that are combinations of other materials, that is some ceramics. And so they can stay magnetized. Iron, nickel, and cobalt are examples of ferromagnetic elements. But there's some materials that they've made that are ceramic materials that are very strong ferromagnetic materials. What happens here is there is a temperature called the Curie temperature. And below the Curie temperature, and think of this as the magnetic field. This is the North Pole and this is the South Pole. The arrowhead is the North and the tail of the arrow is the South Pole. The magnetic field below the Curie temperature, the molecules can line up. The magnetic fields will line up so that the North Pole will line up with the South Pole of the adjacent molecule. Now, whenever they start warming up, these molecules get kinetic energy and they move around. And so and the warmer they get, the more they move, they get more motion. They gain kinetic energy from heat. Kinetic energy is the energy of movement. And so they begin to move in a random fashion. And they're not moving together, they're just one's moving this way and the other may be moving like this, and they're moving in all different directions. And what happens is the randomness cancels out the magnetic field. And so, but above the Curie temperature, they won't be magnetized. But if you go below the Curie temperature, adjacent moments will align. So they'll line up with one another. That's what we see. Now, above the Curie temperature, the magnetic moments are randomly arranged there. They've been moved in such a fashion that they're random. So there's no net magnetic field. So material cannot be magnetized if it gets above the Curie temperature. That includes iron, nickel, and cobalt. And so above their Curie temperature, they can't be magnetized. They become paramagnetic. This random arrangement of the magnetic molecule is depicted in the following slides. Here, think of the green as the North Pole and the peach-colored, pinkish-colored as the South Pole of the magnet. They're randomly arranged. And so you'd have no net moment. You'd have no net North and South Pole on the material. It doesn't have a magnetic field. Let's look at the Curie temperature. Now, above the Curie temperature, it doesn't display magnetic properties. It won't be magnetized. Iron, Fe, and that's your chemical symbol for iron. At the Curie temperature is 770 degrees Celsius. Now, these are Celsius temperatures. We're not going to convert them to Fahrenheit, but just leave them in Celsius. The element cobalt is Curie temperature is 1130 degrees Celsius. And nickel is only 358 degrees Celsius. 100 degrees Celsius is the boiling point of water at pure water at the standard barometric pressure, sea level pressure. All right. And that would be 212 degrees Fahrenheit if you wanted to look at them. Minus 40 is where the Celsius and Fahrenheit are cross and they're equal. Minus 40 Celsius is minus 40 Fahrenheit. 32 Fahrenheit is 0 Celsius. So and they're linear. So you can use the slope intercept equation and see how they work. Now there's formulas for conversion, but we're not going to worry about it any further. Iron oxide, Fe2O3, is 622 degrees. That's its Curie temperature. Now there's a lot of iron oxide in the earth itself. Okay, and so these are Curie temperatures of your common iron, nickel, cobalt, and iron oxide, common materials that we see in the core of the earth. Okay, now that they think is in the core, they haven't bored down to the core to see what actually is there. But the theory is that it's composed of these three materials. All ferromagnetic substances have a definite temperature transition in which the phenomena of ferromagnetism disappears and the substances become merely paramagnetic. This temperature is called the Curie point. Is usually lower than the melting point. Now, this is Hodgkins, Weiss, and Selby. This is on page 3082. This is the chemistry and physics handbook that I used when I was studying nuclear and atomic physics back in 1962. So what we have is this is from that handbook, and there's been no change in this point. That's what the Curie temperature is. And they tell us exactly what it is. Now, this is important to us because we're going to lay it into the next points here. Both the core and the magma of the earth are above the Curie temperature for all of these materials. This means that both the core and magma are paramagnetic. They cannot be magnetized. Keep that in mind. Unless there's something happening due to the great pressure that makes things different. As far as we know, there's no evidence that it should be magnetized. For the Earth is not a permanent magnet. That's my conclusion. Unless there's something about the great tremendous pressures that would change that Curie temperature somehow. Now, most geophysicists agree, according to Lewin, that geomagnetism is generated by electrical currents circulating deep within the Earth. So they take it, what's called the dynamo theory. And a dynamo is an old term for a generator. generate electricity. The currents arise when material moves in the iron-rich liquid of the Earth's outer core. So the iron-rich material moves in the outer core, so currents are created. Though the details of this dynamo mechanism are elusive, this is their theory, and they can't figure it out how it's happened. So it's an unproven theory is what it is. It's an hypothesis, and they haven't tested it to figure out how it actually works. They can't even model how it works. All right. Many theorists now believe that the flow of molten minerals in the outer core forms a chaotic system, and they've come with what they call the chaos theory. And it's a chaotic system. That's the claim. Out of the chaos come periodic magnetic reversals. Well, now, if you have chaotic movement, you're going to get from Fourier series, you're going to get these magnetic movements. But they're claiming that these give you magnetic reversals. Well, if it's chaotic and it's not following a sine wave, a sinusoidal wave, it will generate harmonics, and it will give the appearance of periodic magnetic reversals and a wobbling of the position of the magnetic north. So the magnetic north would move around, which we know it does. So that's what their claim is. But again, this random movement would create, from Fourier analysis, would create these appearances of magnetic reversals. It would only appear to reverse. There's no evidence for asymmetrical movement of the core of the Earth. And by asymmetrical, we mean it doesn't follow, it can't be measured and doesn't follow a pattern. There's no evidence for that, and there's no reason why it should do that. Barnes disputes the dynamo theory in his book, pages 63 through 69, 119 through 114, and 117 through 118. His book is very readable, and it's well researched. There's no known mechanism, according to Shipman, Wilson, and Todd, that by which the magnetic field of the Earth would be reversed. That would reverse it. There's no mechanism. Again, the fact that they don't have a mechanism doesn't mean it didn't occur. Keep that in mind. But it means that they don't have even a way of explaining how it supposedly happened. But again, my point with Fourier analysis, we would get the appearances of it with what they're claiming happens with the magnetic field. A reversal of the magnetic field would require a reversal of the flow of the molten rock in the core of the Earth, entailing massive forces just to change the momentum of the rock. Just think of a freight train traveling down a track. When he tries to stop, it's going to take him a half a mile or a mile or so to stop, depending on how fast he's moving. And the tremendous momentum that they have, it just keeps moving. It has tremendous force. The molten rock that's moving is going to have fantastic amount of momentum. And it's like trying to stop a freight train. In addition, the atheist is forced to accept ridiculously large velocities for the molten rock. It has to move fast. And there's absolutely no evidence that it moves near as fast as it would have to move. And there's some scientists that say that it just can't happen. That can't be the proper explanation. Lewin says this would imply that material in the Earth's outer core was flowing at a speed of several kilometers an hour, which is over 1,000 times faster than the rate geologists have previously assumed. So if this is flowing at several thousand kilometers an hour, that's moving extremely fast. It can move a 1,000 kilometers is about 600 miles approximately. 600 miles an hour. That's almost speed of sound. 770 is about the speed of sound in that neighborhood. 700 feet per second in the air. Sound moves different speeds in different mediums, of course. Keep that in mind. Now, magma is only liquid in a long-term sense. It's a very sticky, thick type substance. Now, About magnetic field reversal, the experience of Apollo has added another mystery to the involved planetary histories of planetary bodies. Once only the Earth and Jupiter were known to have significant fields, and the simple dynamo theory seemed adequate to explain them. Burgess, then quoting Burgess, now with a significant field detected on small, slowly rotating Mercury, while the slowly rotating moon was only at best a small core, also shows a remnant field. The whole theory of planetary magnetism had to be restated. They predicted they shouldn't have any magnetic field for the moon, and Mercury shouldn't have any. Lo and behold, they found a magnetic field, pretty strong one on Mercury, and the moon even has evidence that it had a magnetic field in the past. So, and again, the problem with it is if the moon is not as old as they have it to be, then this magnetic field died out in a few thousand years. But and could have interacted to some extent with Mercury and the Earth itself. Now we go on here. Before the first lunar landing by the Apollo astronauts, scientists had devised relatively simple descriptions of the moon's structure. They had figured out in their minds what it was like, and none of these models was any suggestion the moon possessed or ever had possessed a magnetic field. It seemed highly unlikely that the core of the moon had ever been molten, as the Earth's core still is. They're claiming the Earth's core is molten, but it's under great pressure. Therefore, they should never have had any internal currents. And so then the model says there's internal currents that create this magnetic field. And so it has to be molten for it to happen. And but the investigations carried out during the Apollo missions revealed that the surface rocks had a small remnant magnetism that could have been caused only by exposure to a small magnetic field for a period of at least 1 billion years. And they're assuming some things about the age, of course. None of the several theories that have been developed on account of this is a man named Marion. That's his surname, not his given name. None of the several theories that have been developed to account for the moon's magnetism is entirely satisfactory. In other words, Marion claims none of the theories for it can satisfy what we see. They can't explain it. More information will have to be acquired, and further theoretical investigation will have to be carried out before we have a convincing explanation of the magnetism of the moon. How did it get magnetized? And so we don't know. See? Now, it's possible it interacted with Mercury, and that remnant is due to that interaction. That's a possibility. Isbell and Morrell they wrote, scientists studying data from space physics instruments on the spacecraft have made the major discovery that planet-sized Ganymede, that's one of the moons, one of the planets, possesses its own magnetosphere. The finding indicates that Ganymede, which is 3/4 the size of Mars, very likely creates its own magnetic field. Very interesting. I think that's one of the moons. It's either of Jupiter. I think it's Jupiter, one of the moons of Jupiter, but it may be Saturn. But I think it's Jupiter. Charts giving the distribution of magnetic field intensity on the surface of the globe clearly show that there are important differences from a perfect bipolar field. And in other words, it's not like a standard bar magnet. There are magnetic anomalies that it doesn't follow the rules, what you'd expect, which may be positive or negative, which may be small scale, local or regional, or continental scale, such as a positive anomaly in some area and the negative anomaly in Brazil. Now, so the magnetic field has some places that it's just not following the rules, what we normally would see. We'll come back to that a little bit later. The main geomagnetic dynamo is assumed to be a steady dipole oscillator. That's dipole, it has two poles. That means the north and south pole, and it oscillates, it goes back and forth, rotates. North Pole on top and the South Pole on bottom, and then back to North Pole on bottom, South Pole on top, back and forth. That's what they mean by oscillator, which undergoes a polarity reversal only when it is triggered by random fluctuations of the much more rapidly varying non-dipole field. So again, they're getting into some more of the physics of it, and we won't spend more time on that. One of the most difficult courses in electrical engineering is the waves and fields course, getting into magnetic and electromagnetic fields using Maxwell's equations. James Clerk Maxwell came up with the equations about the time of the American Civil War and told them how to make radio antennas. When there weren't radios, but he told them how they would work. Some claim that either an asteroid or a comet impacted Earth and reversed the magnetic field. So there's different claims about this. Supposedly the field reversals, supposed field reversals. Snyder and Kent determined that neither comet nor meteorite impacts have caused the Earth's magnetic field to reverse. Science News, page 158, and Kerr also, page 916, said the same thing. Now, what I'm pointing out here is that there are a number of scientists and that disagree with some of these claims, and so there's no consensus among scientists about this. Barnes has an extensive discussion of the question of reversal of the Earth's magnetic field. Again, I would refer you to Barnes's book. It's still available. I think it's still in print. Thomas G. Barnes is his name. I have not repeated the arguments made by Thomas G. Barnes. I'm not going to repeat them. I suggest you purchase his book and read it if you have a technical background, and read his book. Now, here we have a situation. Now, understand the impact of a comet or asteroid, a small asteroid, is supposedly going to reverse the field. That's the claim. How can an impact giving a 10 to the minus 9 change in Earth's angular momentum? That's the rotational speed and momentum in rotational form. 10 to the minus 9th is 1 part in a billion. And so it's -9, you take the decimal point, put the number 1, and put a decimal point in front of it, and then just you put 9 zeros in there. And you put 8 zeros in the number 1. And so it would be 9 significant figures. And so it's a decimal point, 0, 0, 0, and put 8 zeros in a 1. And that's how much change. So a comet or something like this nature would have a 10 to the minus 9 change in Earth's magnetic momentum. How can they produce a magnetic reversal when atmospheric drag, just the drag of the atmosphere, produces a 10 to the minus 7th factor? That's 100 times stronger. If you look at the 10 to the minus 9th and 10 to the minus 7th, it's 100 to 1. 10 to the minus 7th is 100 times bigger than 10 to the minus 9th. And so the drag of the atmosphere doesn't have any effect on the magnetic field. We can't find any effect. There's no associated effect of that. Again, that's our argument. It makes perfectly good sense. And all of these characteristics of the Earth's field operates like a remarkable symmetrical oscillator. This is Cox. Cox claiming it does. Again, they're claiming it oscillates. Now, we'll show why they have to claim this and as we develop this. Electrical oscillation, however, requires both inductance and capacitance. So we must have an inductor and a capacitor to make them oscillate. Reliable estimates of the inductance of the Earth is 1 Henry. This requires a capacitance of 2.5 times 10 to the 21st power farads for a frequency of 1 cycle for every 10,000 years. That's what it would require to oscillate at that rate. And a 1 farad capacitor, in just recent times they built them. Of course, you're taking the whole Earth, claiming it's a 2.5 times 10 to the 21st power farads and capacitance. But the atheist is forced to claim the reversal rate is on the order of a run reversal every 10,000 years. Now, if we have capacitance and inductance of those values, we'll get a periodic change that will not be random. It would oscillate at that frequency back and forth every 10,000 years. It would oscillate back and forth. And so unless the capacitance and inductance changed, that frequency would be constant, be a constant frequency. And so the atheist is forced to claim the reversal rate in order of a run reversal every 10,000 years because the evidence is clear that the field wouldn't be too large if extrapolated back in time at its present rate of decay. So if they use uniformitarian arguments extrapolated backwards, then they get a problem with it because the magnetic field would be too large. What's the problem there? A large magnetic field creates a lot of heat. And another problem with this theory is that it would make the reversals be periodic, and atheists deny they're periodic. So again, we got a problem there. They deny they're periodic, and they'd have to be periodic if we had a capacitance inductance that weren't changing by very much, and it would follow that cycle an oscillator does. Apparently, Marion, again, that's not me, but his surname is Marion. He's a writer of a physics book, author of a physics book. Apparently, the field undergoes a decrease in strength lasting about 10,000 years. Then comes a period about 1,000 years in which the reversal takes place, and finally there's a buildup of the field from the opposite polarity. This same process is repeated with intervals of 50,000 to a few million years. So they're not periodic, according to him. They don't repeat at the intervals. Now, how are you going to get this to oscillate without these two sources? To make the oscillation occur, you need inductance, capacitance. And the inductance capacitance would make it oscillate at the same frequency. The last reversal occurred approximately 12,400 years ago, according to Marion. Okay. Since the time of Gauss, this McDonald's Guns. Now, these are the fellows that have written for the federal United States government. Since the time of Gauss's measurements, the Earth's dipole moment has decreased sensibly linearly at approximately the rate of 5% per 100 years. That's their claim. Assuming these rates to persist, our analysis discloses that the dipole moment will vanish in AD 3991. We won't have a magnetic field anymore. It'll be gone. That's McDonald's Guns. That's government published document. For 2 points, from 2 points, if it's linear, and you'll get this in junior high. My children took this mathematics in junior high school, and so we can use the point intercept or slope intercept form of equation and get a linear equation. From 2 points, 1989.6 Gauss and 3991 0 Gauss, we can derive an equation from a line, the slope intercept, assuming it's linear. But the variables b, the field strength, and t, the time of the equation, becomes, we get this following equation. To get b, the field strength, is minus 2.997 times 10 to the minus 4 t plus 1.196. And so that's your value, that's your equation. So if we plug in the time t equals 0, that would be the birth of Christ. The field strength would have been 1.196 Gauss, according to the field strength. And if we project backwards on it, from the equation derived from the assumptions of McDonald's Guns, assuming it's linear, say, the Earth's field strength would be 1,000 Gauss in about 3.3 million years. It was extrapolated backwards in time. Again, these fellows use linear extrapolation. And they're saying this is linear, so we can use linear extrapolation on it. But 1,000 Gauss is the field strength of the sun, for crying out loud. So that's ridiculous. The crust of the Earth would melt long before that time from induced currents, induced by electromagnetic induction, producing heat. Power is I squared R, the amount of current squared times the resistance of the Earth's crust and the Earth itself, produce a tremendous amount of heat. And it would have melted the crust of the Earth. It had been molten. The occurrence of this kind of, and so it becomes ludicrous. So that's why they have to have it cycling every 10 or 20,000 years if they project this backwards. The occurrence of this kind of polar shift has been suggested. This problem with the field reversal theory now has been suggested for the reason that no force capable of shifting the axis has ever been imagined, other than possibly a major planetary collision. That's the only thing. With the second way of shifting the poles would be not to change the direction of the axis, let it point in the same stars as before, merely to shift the Earth around on its axis so that different places on the surface would be at the poles. So that's a shift the crust of the Earth. Suggestion also has run into difficulties. And what they argue here is they keep coming up with this. One group of scientists shoots down another one's views, okay? And so all you got to do is cite some of the scientists. They'll shoot down these various views. The main obstacle to such a shift is the stabilizing effect of the equatorial bulge on the Earth. Remember, we talked about the equator bulging on the Earth like a spinning top, a gyroscope, more or less. The Earth is not a true sphere, of course, but a slightly flattened spheroid. Remember, we talked about the oblateness of it. During the 19th century, some of the titans of geology, including James Clerk Maxwell, and Maxwell was knowledgeable in not just geology, but he was knowledgeable in physics and mathematics as well. He was a genius, no doubt in my mind. He was one of the great geniuses of modern, at least modern times. He lived around the 19th century. And Sir George Darwin, that was the son of Charles Darwin, considered this problem, and they decided that the stabilizing effect of the equatorial bulge was so great that no conceivable force visiting within the Earth could make it shift on its axis. They therefore dismissed this idea of any shift in the poles. Any shift in the poles is impossible. A third way to conceive of polar wandering, this is Hapgood now. Remember, Hapgood's book was endorsed. The foreword was written by Albert Einstein. I have two. Hapgood wrote two books. I have both of them. A third way to conceive of polar wandering is through the sliding of the Earth's whole outer crust over semi-liquid layers below. I believe that this could have happened during the flood. This idea was suggested long ago, but like most good ideas, but the fellow who first advanced the notion, Damien Drackgeyer, did not have enough influence, though he wasn't influential enough to impose the idea on his contemporaries. He didn't have enough social status in the club, if you please. Every few 100,000 years, and this is back to Lewin, the direction of the Earth's magnetic field reverses. Until now, everyone assumed that it happened gradually over 1,000 years, but a team of geophysicists in the U.S. and France have found evidence reversal may have been much more sudden. What's their evidence? Well, it's molten rock that's solidified that we talked about earlier. This would imply the material in the Earth's outer crust was flowing at a speed of several kilometers an hour, which is about 1,000 times faster than the rate geologists have previously assumed. So again, we have a ridiculous speed of the flowing of the magma, the material, in the outer core of the Earth. We get some other problems. It appears, now remember, they say the convection current, the movement of the molten rocks creates a current, electrical current, which then creates a magnetic field. Now, a current would create a magnetic field. Now, it would be an electromagnet if it did happen. So that point could occur. It appears that these mantle convection currents, now remember, convection current is where something moves. If you have an old radiator in a car, and they used to have a steam radiator that would heat the room, the heat would rise, the hot air would rise as the molecules bounce apart and it becomes less dense. So it rises to like a hot air balloon would go up and will rise to the ceiling. And it moves along the ceiling as it cools off, then the molecules begin to drop down. So this cycles the air throughout a room without a fan, just by convection current. Heat can move in three ways: radiation, convection, and by contact, by conduction. So again, they talk about mantle convection, the actual movement of material. It appears that these mantle convection currents occur at rates of a few meters per hour per year at the most. We're not dealing with the liquid medium, but the solid, and it's only in the time scale of hundreds of thousands of years that the mantle behaves as convection fluid. Now, this is the claim. So again, we get another problem. They don't have that speed of movement that they need for this thing to occur. It just doesn't move fast enough to create enough movement. What happens with an electrical current? The faster the current moves, the more the field creates a voltage and creates a magnetic field. The magnetic field occurs because of the movement of electrons, movement of charged particles, either electrons or protons. And so that movement, if they move very slowly, you don't get a very strong field. The faster they move, the stronger the field is. So you kind of keep that in mind. So if they're moving very, very slowly, you don't have a very strong field. Cox wrote the dipole field decreased during this time at a remarkable uniform rate. It will, if the rate remains constant, pass through 0 point. Again, now Cox is talking about a constant rate of movement, linear movement. And about 2,000 years from now, it then reverses polarity. So it's going to pass through and reverse. According to him, it's a linear movement, constant. Constant means linear, and that means it's going to generate harmonics from the Fourier analysis. And so, again, that would give the appearance of reversing fields if it was indeed linear. I don't think it's linear, but they have a problem with it. Another problem we run into, and I hope I can finish this, we have problems with the field reversal. Certain bacteria, insects, birds, and fish seem to have used miniature magnetic compasses, needles, and made of magnetite. I'm going to stop on this. I'm going to pick up with this on our next lesson. Pick this up on our next lesson, and we'll come back into this. Are there any questions? Anybody? Well, we'll come back here.